Hello, my name is Michelle Backus, Environmental and Resource Management Agent with Rutgers Cooperative Extension of Middlesex and Union Counties. And today I'll be speaking to you about how to make your compost pile or compost bin a success. This presentation was originally developed by a team at Rutgers Cooperative Extension as part of a community gardening training series for master gardeners. So what is composting? Composting is a natural process where organic materials decompose and are recycled into a dark, rich, crumbly, earthy-smelling material known as compost. Organic material is material that was derived from living matter. Compost is not considered a fertilizer as the nutrient content is low. It is a soil conditioner. Composting happens when organisms in the soil break down or decompose the organic material. The dark, rich, crumbly material that results is compost. Many organisms are involved in making compost, including worms, insects, arthropods, mites, millipedes, bacteria, and fungi. There is incredible species diversity in the soil that together forms the soil food web. Energy and nutrients are converted into different forms as one species eats another, as indicated by the arrows in this diagram. This diagram from the United States Department of Agriculture, or USDA, is a simplified model of the soil food web. Several connected trophic levels make a food web. A trophic level is just a level of the food chain. In this diagram, the basis of the food web are the photosynthesizers, which are the plants that are then broken down by the next trophic level, the bacteria, fungi, and nematodes, which are in turn broken down by higher order species in the food chain. The soil food web and composting is a great way to teach youth about relationships in ecosystems, the cycling of matter, and reducing waste. There are many benefits to using compost. By incorporating compost into the top 4 to 6 inches of the soil, the structure and texture of the soil is improved. A crumbly substance like compost is often just what soil needs to improve its workability. Garden soil should ideally have about 3 to 5% organic matter. Compost can meet this need for all soil textures. Incorporating compost can improve soil aeration, which is important for plant roots. Airspace in soil stimulates healthy root development. In clay soils, compost can help improve soil drainage. Anyone that has clay soils knows that they are very slow to drain. On the other hand, compost acts as a sponge, holding on to water and nutrients from, for example, fertilizers, decreasing the need for watering and repeated fertilizing. This can be a benefit in sandy soils that drain out and dry very quickly. The organic matter in compost sustains the many microorganisms we reviewed in the soil food web. In turn, the microbes convert organic matter into nitrogen and other nutrients that the plant can easily assimilate. It's important to remember that although compost has small amounts of nutrients that are released slowly throughout the growing season, compost is primarily considered a soil conditioner rather than a fertilizer. Compost helps to control soil acidity. Many composts have a neutral pH, approximately 7. Most plants take up nutrients most effectively when the pH is slightly acidic, about 6.5 to 7. If the soil pH is below 6.5, then adding compost will help to move the pH into the happy zone, where nutrients are absorbed most efficiently. Compost supports sustainable gardening and landscaping in that we are less dependent on outside chemical inputs. If the soil is contaminated with lead, for example, compost helps to bind lead in the soil, reducing the potential for plants to absorb lead. In addition, compost helps keep the soil moist, which reduces lead-laden dust in the air. Compost saves your town money because of the reduction in garbage the township has to process. In addition, when you compost, you are reducing the amount of waste going to landfills. We often focus on the benefits of composting for soil and plant health and leave out this important detail. More about this in the next slide. As we just said, composting can reduce the costs and environmental problems associated with municipal garbage collection, transportation, and disposal. This pie chart shows that about 53% of the waste stream can be recycled. 34% of the waste stream are considered organics, meaning yard and food waste, which can be composted. That means that 87% of the waste stream can be recycled in some way. The other 13% goes to a landfill. In addition, lawn grasses are composed of about 75 to 85% water. Grass with 85% water content equates to about 1,000 pounds of water a season being thrown away, which is a big waste of water if you are irrigating a lawn. So let's talk about how we make compost. In order to successfully compost, you must have both nitrogen and carbon-rich materials. We call green material the nitrogen-rich materials, such as kitchen scraps, grass clippings, and weeds. We call brown material the carbon-rich materials, such as leaves, hay, or shredded newspaper. It is important to cut everything up into small pieces for faster decomposition. How small depends on how much time and energy you want to put into it. Just understand that the smaller the material is, the faster it will decompose. There are many items that should not be added to a community, school, or backyard compost pile. Meat, oil, and grease attracts rodents and other wildlife, so it should not be added to the pile. It does not decompose well and it smells bad. Animal and pet waste have bacteria and other organisms that pose a health issue, and these items should not be added. Diseased plants that have fungal spores and other disease organisms, bacteria, viruses, should not be added because they could spread to your future crops. A home, community, or school compost pile may not generate enough heat to kill these organisms. Some gardeners have had problems with weed, fruit, or vegetable seeds sprouting from the compost. If you don't think your compost pile will reach the necessary temperatures to kill seeds, then better to leave out seeds you think will germinate. The USDA requires commercial compost operations to keep their compost between 131 and 170 degrees Fahrenheit for 3 days in order to kill pathogens and weed seeds. Unless you are monitoring the temperature of the compost, it is best to leave these materials out. There are many different composting techniques. The really lazy way involves adding material to the pile, setting it where it will rain because the organisms need moisture in order to flourish, and in about 12 to 18 months you will have compost. But with just a little more work, you can have great compost much sooner. All methods need patience and a willingness to experiment with the materials you have available to you for composting. Next, we will discuss the extra effort involved to get finished compost faster. Ideally, the pile should be located out of direct sunlight, out of exposure to high winds, and in an area where it won't be in the way. The reality is that you may not be able to control for all of these variables, and the compost pile or bin should just be put out where it is most convenient for composting. Ideally, it should be close to a water source so you can add moisture when it dries out, away from areas of poor drainage, and away from wooden buildings or trees. The microorganisms in your pile need moisture to break down material. The proper consistency of the moisture would be like a damp sponge. If you squeeze a handful of the compost, a few drops of water should come out. Someone should monitor the pile for moisture and add water when it is too dry. In addition, the microorganisms in the pile need oxygen in order to thrive. Turning the pile about once a week during the warmer weather helps to aerate the pile and speed up decomposition. During the winter, the pile can be turned less often so the heat is retained. Organisms need carbon-rich material, the browns, for energy, and nitrogen-rich material, the greens, for protein. How much brown and how much green material to add is determined by the amount of carbon and the amount of nitrogen in the material you are using for composting. Scientists have determined that the ideal ratio of carbon to nitrogen in a compost pile is about 30 parts carbon to 1 part nitrogen by dry weight. Different materials have different carbon to nitrogen ratios. In general, fresh material like veggie scraps and grass clippings, the greens, will have a lower carbon to nitrogen ratio. Leaves, newspaper, and straw, the browns, will have a higher carbon to nitrogen ratio. This chart shows the carbon to nitrogen ratio of different materials. Notice that the vegetable scraps have less carbon per 1 part nitrogen than, say, newspaper or sawdust. The items at the bottom of the chart have more carbon per 1 part of nitrogen than the items at the top of the chart. Here's an example we can use to determine how to reach the 30-to-1 ratio in a compost pile. It is helpful to understand these numbers, but do not get too caught up in them. Just know that the carbon to nitrogen ratio is one factor to consider when you are composting. Now for the example. Grass clippings have a carbon to nitrogen ratio of about 20-to-1. So for every 20 parts carbon in the grass, there is 1 part nitrogen. Dry leaves have a much higher carbon to nitrogen ratio, about 60 parts carbon to 1 part nitrogen in the leaves. To achieve that ideal 30-to-1 or something close to it, you can add 2 bags of grass clippings for every 1 bag of dried leaves to get about a 33-to-1 ratio, which is close to 30-to-1. The question then becomes, if we need more carbon than nitrogen for effective composting, why do we need 2 bags of grass clippings, our nitrogen-rich material, and only 1 bag of leaves, our carbon-rich material? The answer is that grass clippings have a high water content. Remember that the 30-to-1 ratio is by dry weight. If we were to dry down those grass clippings, it would not be a lot of material. It is helpful to have dried leaves or some other carbon-rich material on hand stored somewhere and add them to the compost pile whenever adding fresh green material. When the bin fills up, start a new pile. Now we'll talk about pile size. Your compost pile should be no smaller than 3 by 3 by 3 feet. Any smaller and the material in the pile will not be able to retain heat. For example, in the picture on the right, although this bin may be convenient for a school environment, it is probably not large enough to retain the heat needed for the composting process. The pile should also not be larger than 5 by 5 by 5 feet. Any larger and it will not be manageable. Which leads us to the question of why does the material get hot? The simplest explanation is during the decomposition process, the organisms are oxidizing the carbon material and converting it to carbon dioxide. During this process, a great deal of energy is released as heat. If you decide you want to monitor the temperature of the pile, compost thermometers are commercially available. The pile can be turned once it reaches about 140 degrees Fahrenheit or higher. Here is a typical backyard compost bin. Note that it is vented to allow air in, and the bottom has an opening to scoop out the finished compost. The lid helps keep animals and excessive rain out. A community or school garden may need several of these units. Some counties and municipalities may have compost units available for residents. They can be purchased through garden supply companies, garden centers, and big box stores. For these types of bins, the material is added at the top, and over time finished compost can be accessed from the bottom. This model is called the Soil Saver. Other models such as the Earth Machine or Garden Wise plastic compost bin are available. Some counties have composting demonstration sites, for example the Ocean County Recycling Center, Mercer County Home Compost Demonstration Site, and Middlesex County's Earth Center. These turning units and bins are commercially available and are on display at the different county sites. Compost bins can easily be made using wire fencing and stakes or wood pallets. A wire mesh holding unit is inexpensive, easy to build, and can be easily moved. The material can be added in layers, and then the fencing is easily removed so the pile can be mixed. The fencing is then reconstructed and the material is put back in. Different types of constructed holding bins are also on display at demonstration sites mentioned previously. Again, the minimum size would be 3 by 3 by 3 feet and maximum of 5 by 5 by 5 feet. You'll notice the picture on the upper left shows a wire mesh compost bin with no posts. Posts provide more stability but make the bin difficult to move. Without posts, it's easy to lift and provides access to the compost that is already done at the bottom of the pile. The concrete block bin on the upper right is sturdy, durable, and easily accessible. Make sure to leave spaces in between the concrete for air. Now we'll discuss managing the compost pile and correcting problems that may come up. Oftentimes, correcting a compost pile gone bad is pretty easy. It's just a matter of figuring out the problem. This chart shows a number of different issues that may arise and how to correct them. For example, if the pile has a rotten odor smell, it's possible the pile is too wet. Turning the pile, adding dry materials such as sawdust or wood chips may help. If the pile is not getting hot enough, maybe it is too small and it needs to be turned more frequently, or it is not wet enough. In a community or school garden, it is important to have a plan for managing the compost pile or bin so it does not get out of control. Here are some things to think about. Who will manage the compost pile? It is best to have a point person or a small team who are responsible for monitoring the compost. They would be in charge of monitoring for moisture, making sure the pile gets turned, and making sure the wrong materials don't get into the pile. Think about where you will get your brown material from. Often the biggest problem in a community or school garden is having enough carbon-rich material. Often greens are available from the community garden, but brown material, for example dry leaves, are not available in the necessary quantities to have success. Speak with the property manager about providing dry leaves during the fall or encouraging gardeners to bring dry leaves from their home. Have a long-term plan for storing these materials. Does your compost area fit your setting? This picture shows a compost pile in a community garden, but it may not be best for a school setting depending upon the setup. What will happen with the compost in the summer? Is someone available to turn it? Have a plan for how the finished compost will be used. And finally, signage is definitely important in the compost area so people don't think it is a garbage bin. Use the sign to remind people what they should not add and to cut scraps up into small pieces. If pests are a problem at your site, for example rats, raccoons, or even insects like flies, make sure to keep the pile covered and turned. It is important to keep the veggie scraps turned under and covered with a few inches of leaves or whatever brown material you are using. You may also consider a commercial compost container with a lid that can be locked. Consider also placing the compost pile on a concrete pad or paved area if rats are a problem. Rats are burrowing animals and will not be able to burrow through the concrete. Once you have finished compost, it is best to incorporate the compost into your soil before planting the garden. When using the compost, apply 1/2 inch of compost to the soil surface and then till the compost into the top 6 inches of soil. 3 to 5 cubic feet of compost will provide a 1/2 inch layer of organic matter over a 100 square foot area. Compost can also be used as a mulch throughout the growing season. This composting video is available on YouTube, which was produced by Rutgers Cooperative Extension of Middlesex County. It provides a good summary on composting and is about 5 minutes long. In summary, composting is easy, especially if you understand the science behind it and can do some planning for managing the pile in a school or community garden. Remember that nitrogen from the green material, plus carbon from the brown material, plus oxygen from turning the pile, plus water from moisture will equal composting success. Now is the time to ask any questions you may have. Thank you for attending this program. Here is a list of other Rutgers Cooperative Extension community gardening lectures that are also available. A team of Rutgers Cooperative Extension faculty and staff developed these presentations. Here are additional content and photo credits. Thank you for attending this Rutgers Cooperative Extension program. Need more information? Rutgers Master Gardeners are trained volunteers who provide research-based information from Rutgers Cooperative Extension, the New Jersey Agricultural Experiment Station. Rutgers Master Gardeners operate garden helplines in their local county Rutgers Cooperative Extension office that you can call, email, or visit. You are welcome to bring samples of vegetable plant problems and insects to the office for identification and management advice. Rutgers Master Gardeners are a great educational resource for your community garden. We wish you the best harvests in your community garden.